Right, colleagues. So welcome also from our side, in particular also from my side, to this webinar of the vera.ai EU project. We are quite pleased that the project has picked up this very important topic of C2PA, and the work what we have done in the consortium is certainly creating a huge impact, what we hope for the time to come as well, not only now, but also for the future. And what we want to do now together here is to give you some insights on what the title says, the work what we've done on trusted content provenance and authentication with this prominent technology of C2PA. Badr, some words about you?
Yes, I'm Mohamed Badr. I'm from the Department of Technology and Innovation at the EBU, and we've been working on the topic of C2PA this past year and on content provenance and authenticity in general. I'm very pleased to be here and share the work we've done in the vera.ai project.
Cool, thanks. Thanks for coming in. Next slide, please. So the what if is the question. What if there would be a way how we can undoubtedly know who is claiming the content, how was the content produced? And this can be, when we say content, it can be audio, video, images, also text in the future and so forth. Where was the content coming from, and when was it published? I mean, we are all aware about this time of fake information, fake news, and the pictures what we show here were clearly faked in terms of showing Trump's arrest once a while ago, or fake videos of which were coming from a hacked website of the Ukrainian TV. So this poses the question, and in particular it poses the question for those who are having a consumer-facing tasks, such as public service media operators, but also social media channels, etc. and so forth. But for us at the EBU, particularly important is whether we can have technologies which would help us actually in this task to avoid fake information to the public, or which allows journalists right from the beginning also to identify whether content has been altered or changed. So there are a number of tasks ahead of us. And then finally, how can we also increase the trust vis-a-vis the audiences? This is for our public service media broadcaster a fundamentally important task. And what we have identified, what we are going to show you throughout this conversation in this webinar now, that the technology C2PA is giving us the tools at hand in order to enrich the trust from our audiences. Next slide. So the C2PA initiative is actually a couple of years old already. It is called, in terms of the abbreviation C2PA, the Coalition for Content Provenance and Authenticity. It allows you to track the media changes throughout the whole supply chain, which means from creation until to publication. It's complementary to the vera.ai verification approach, part of the same ecology for fighting actually this task to avoid disinformation. The adoption on the market is already going on. We have a number of EBU members, such as Deutsche Welle, WDR, France TV, BBC, CBC, AFP, and many other major industry actors who are providing now the tools, adopt the technology in their products, and make it available for the integration in the workflows. Next slide. The background is actually has started between a relatively small consortium. This was called the Project Origin. Was coming from CBC, Microsoft, the New York Times, and BBC, to prove a media source of origin, and it has not been altered along the supply chain. This was the initial idea, and it was also a number of technology companies which came into this game. Afterwards, the Content Authenticity Initiative, the CAI, was formed. It has, as he has written on the slide, a huge amount of members, including also social media companies and also big tech companies. And this actually has developed an industry standard for the provenance of metadata, protect creative content of artists, combat content theft, a responsible labeling of AI generated content, and so forth. Next slide. When you go to the website, and you can do this after the talk, hopefully, not now, you will see a huge amount of participants in the C2PA initiative. The C2PA is an industry association. It is not a accredited standards body such as ITU or ETSI, who you know, or SMPTE, but it is developing the standards. It's developing specifications and even more. There are, of course, some working groups. There's an official governance structure, and you see the members of this group is huge and very impactful. Big software companies are there, AI companies are there, hardware manufacturers of cameras still, and also moving picture cameras, other industries you will find there. Next slide. So how does it work? And this is already an image which is pretty important in terms of what does it tell also the consumer. So a consumer might see a photo, in the future also might see moving images, a video. And then he has the opportunity to see that it has content credentials, CR. This is the label which gives an indication and hopefully of trust. There were investigations done by our colleagues from the BBC a while ago, whether giving this additional information to the consumer enhances the trust. And the answer was yes. So this is a means of allowing the audience of our content to appreciate where was the content coming from, was it verified, was it altered, by whom was it altered, for what purposes, etc. and so forth. And it enhances the binding between the content providers and the consumers' content credentials. Next slide, please. And here you see, for example, how this could look like for a consumer. The consumer clicks on the label and gets additional information. This image combines multiple pieces of content on purpose. This is permitted because it was part of the creative process, but it was verified and was then subsequently also published. It's by creative intent, but it was not unforeseen or faked.
So picking from the previous example, here on the further right side, we have the prompt content. So the content that the consumer gets. We can also see the time it was published or also created. And here, just in the previous step on the provenance chain, we can see that the content looked like this with a penguin into the desert. This image also has content credentials, which was created from two other separated assets. The first one being the original content with the CR icon. This is the image which was camera captured. It also has a CR icon. And this was the desert picture is another asset without content credentials. So content credentials, they are permissive. They allow inclusion of content with or without C2PA. But as long as the signer of these components is being transparent, that is okay and permissible by the C2PA specification. So the provenance chain can be abstracted and looked at this way. We have an original content, which could be a photo, a video, or a piece of audio, or even text. This media asset has some provenance information, and this provenance information is bounded to the asset through a digital signature. This is the core security of C2PA, and it is well described into the specification. These three components are bundled in what we call a manifest. So manifest is the technical term of content credentials. And this manifest travels along with the content throughout all its history and throughout all processes that make changes to this content. So if this content gets altered by another process, then a new set of assertions are created with a new digital signature while attaching the previous manifest, so it extends the provenance chain of this content. So it's very important that each entity that makes changes to the media asset, it also provides a manifest describing those changes and provenance information. So how does that work? It goes through a process that we call claim generation. So the claim is a bundle of provenance information with what we call the cryptographic hashes of the content, which are then signed by identifiable entity to provide the source or the identity of the signer who vouches for the claim and for the assertions and for the changed content. And this is what establishes this trust between the publisher, which is the signer, and also the consumer, which will be validating these content credentials. So these content credentials are metadata under the hood, and they are attached with the content. So they could be stripped by non-C2PA compliant social media platforms, for example, or other processes that would not add this layer of manifest. But there are other means and mechanisms that C2PA describes thoroughly in their specification to provide this durability of content credentials. It relies on watermarking and fingerprinting technologies to make these content credentials recoverable. So a manifest looks under the hood like this, as it has a bundle of assertions. These are readable by verifiers and could be parsed. Then this provenance information are cryptographically hashed so that any changes to the assertion will make the claim tamper evident. And then this claim is again signed by an identifiable source. This is the signer. This could be the publisher or the hardware and software that has signed this asset. And this manifest is cryptographically bounded because also the hashes of the content are included in the claim, which gets signed. So even a change to the asset will also render this manifest unverifiable. In the verification side of things, a verifier is a process that will output two states to simplify things. Either the content was verified, its content credentials were verified, or they were tampered with. So it starts by recomputing the hashes from the provenance information along with the content and then verify the signature. It also performs public key infrastructure verification when it contacts a certificate authority to get a status about the signer, whether its certificate has been revoked or not. So these are other checks that are performed to verify the digital identity. And it also verifies a timestamp, which can also be included in the content. This is a trusted timestamp token, which also provides cryptographic means to verify the timestamp of the generation time. And then once the certificate has been verified, it is checked against what we call a trust list. So every verifier has a trust list. There are two major verifiers. One, the C2PA trust verifier, contentcredentials.org, which has as a dedicated set of certificates within its C2PA trust list. And then there is another trust list for news publishers and called News Origin Publishers List, and this is a different trust list which only has certificates of publishers. The verifier is also where the recovery of a stripped manifest happens. For example, if the content being verified does not come with this content credentials, the verifier then, with the help of a soft binding mechanism and watermarking, it gets back the recovers back the stripped manifests. So this is here's a way to think about stripped C2PA metadata. You can imagine that C2PA given these guarantees on the first row. So it's not durable against metadata stripping. This is obviously the case when the metadata is simply removed from the files. It's not durable against a removal attack, as I said, but it provides strong cryptographic binding. It is detectable on C2PA enabled apps and does not require any network for some verification. But in some other cases, it will require that the certificates, for example, gets verified by the verifier. But in combination with fingerprinting and watermarking, this provides even stronger guarantees because the fingerprint is durable against attacks because fingerprints are computed from the content themselves. If you remove the content, then there is nothing to verify anymore. So the fingerprint is in the content, computed from the content. The watermark is also embedded in the content. Its security is such as it's very hard to transfer a watermark from a content to another, provided that we are using closed source watermark algorithms. But since C2PA is an open standard, there are initiatives to provide open source watermarking tools, but those have also their drawbacks with the security. So they need to be combined with fingerprinting approaches to provide the better security and authenticity guarantees. From a display perspective, content credentials need to be displayed in a way to set up trust. So made we the 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 basic set of provenance information is the digital source type, which states of what source type is the content being verified. Is it camera captured? Is it synthetic or AI generated? Does it include AI edits? This is giving the consumer of that content a general overview. It can also provide the consumer with different assertions as of review of claims or fact checks or any provenance information really that was embedded into the content credentials.
I think
Here on the
it's also fair to say, Badr, yeah, that the discussion at the moment is still open about what do the content owners, broadcasters, for example, want to show.
exactly.
I think it's pretty obvious that you don't want to reveal names of certain individuals, such as a journalist in a crisis region, something like this. But the important message is that you have a lot of freedom as a broadcaster, content owner, to decide what you want to reveal. Huh? Isn't that true?
Yes, that's exactly the case. So uh, revealing it's an opt-in, it's totally opt-in. C2PA, you can choose what kind of information you'd like to put in to those content credentials and what you'd like to publish there. For example, there will be cases where you'd like to publish, usually in the internet, you publish restricted information while keeping things transparent as much as possible. But from a B2B perspective, you can assume that other kind of assertion will be transferred through content credentials. So definitely. And picking on the example on the right here, we have an image that was published by CBC Radio Canada. It lists here the photojournalist that published it and also the date when it was captured. So this is the date of the capture, and then there is the date where these content credentials were issued before publishing. So the content credentials were issued by CBC Radio Canada on the July 15th of last year. So that was the display. Here we would like to focus more also on the source of the content, since this is where the ground truth of content relies. So it starts from the camera. Here there is already several camera models that provide this C2PA feature for images. This is the M11, like M11P was one of the first uh, or the first implementation of C2PA within a camera. And then most recently, Sony just released an camcorder which provide video authenticity through C2PA for videos captured with the camcorder. Uh, the most important provenance information included are the date and time and GPS location. Those information are also totally opt-in. They can be enabled or disabled depending on the implementation of the cameras, and also depending on what kind of information is released afterwards. Another way C2PA is being used in practice. So the BBC did a demo of C2PA in their website where the BBC fact-checking team used it to bind fact checks to content. So mm, for example, in this video, they took a video from TikTok and they performed fact checks. They included their findings within C2PA and then signed them. So whoever is verifying this video will also be prompted that these fact checks were provided by the BBC, and this is what the BBC is claiming about this content. Um, this provides and or adds another layer of authenticity as of the consumer of that content could verify where the source is coming from, and even if the BBC has really published those fact checks or not. Um, So now in the next couple of slides, we'll be discussing how C2PA can be combined with the different Vera AI tools that were developed or enhanced within this project. And we will discuss the three following tools. So the first is keyframe selection and enhancement, which is a tool for video keyframe extraction and detection. We will see if we can search and trace the different keyframes and how C2PA can be enabled with that. Second, we will see how C2PA can be integrated with the synthetic image detector to find, for example, similar detection of an image and get back its C2PA metadata. And for the database of known things, we will see how C2PA could be included to add this additional trust signal for the fact checker when they are debunking claims. So why sign-in a detection? So with all the benefits that C2PA provides, we believe that sign-in a detection will provide uh, uh, a secure mean to provide an integrity for a detection report, which will also be tamper evident thanks to the security properties of C2PA, provide secure timestamp that cryptographically proves when the detection process was conducted, and finally, media assets could also be stored in an external database with C2PA metadata, so that detection does not have to run each time, but with a C2PA soft binding mechanism, we can get back the results of a detection, which also are authentically signed with C2PA, so to avoid pre-running detections. So here we consider an example of detecting an image with a synthetic detection tool. This was an initial version which was also in development of the tool, which is also deprecated, and earlier results showed three detection models with 63% probability of the AI being checked is AI generated, and 2% and 1% for the other other models. So the detection was inconclusive. It was limited. The tool was also limited to three models only, and also it took time to run each detection uh, each time this image was uploaded. So how C2PA could be added with this is that the detection of this result could be bundled in a C2PA manifest. So in the left side, this is the consumer facing manifest, and then the right side, this is the more technical metadata. So the image, once it has been run once by the synthetic image detector, it could be signed by the tool. So this is the claim generator that signs it. This is the version 1 of the claim generator. It is then signed by the tool itself. So this image was signed yesterday. And again, it provides also the assertion of the provenance assertion of what action has been conducted on this, which is a detection action. So here's also gives a brief summary as the image detected was synthetically detected with a low probability of being generated. And so this is under the hood. So in the same manifest, we can get the exact probabilities, which were also included into content credentials. So here we can see that this a limitation of the display as it wouldn't show the information from the manifest about the probabilities, but the probabilities are there, it's just they are not shown. Um, So this was an initial detection, but again with C2PA, since it's a provenance framework, we can imagine that with another iteration of the tool, we will get, which was the case toward the end of the project, the tool that was delivering supported even much more models. So there will be new models, meaning new provenance information to be included for that image, up to 9 models for the latest version of the tool. Which now shows very conclusive results for the Trump image. But again, it will still require that images are detected at least once every version of the tool. But now with C2PA, we can extend the provenance information of the first detection. So all the images that are similar to this Trump image will also the results of their detection will also be valid since they are very similar to this image. And the new manifest is then signed by the newer version of the detection tool, now 2.0, which was signed on again, the signature or the date the detection was performed, and the action now says that it detects that the image is with a high probability. And under the hood, the different probabilities also recorded by the manifest. Here we get the different the different models with the probabilities under the hood. So this shows that C2PA can provide, thanks to its provenance specification, you can provide a way to extend the provenance of detections. So when a fact checker is or is trying to detect if an image is AI generated, a cached result could be rendered back instead of rerunning detections, and the result can be authentic since they were assigned by the tool itself. So these are here are the key takeaways for detection tools or models are not static, they always get improved. And in combination with provenance techniques, C2PA and locality sensitive hashing, this is to detect if an image under detection is similar to an image that was already detected and it was cached. So this technique can reduce computational overhead. And also C2PA, as we've shown, gives the history of previously run models and also the provenance of those models. And finally, the image detection tools, results can be archived for redistribution afterwards, or also can be added in report or fact checks, given that the verifier, the client verifying the content trusts the claim generator of the synthetic detection tool. So that was it. Yes, Hans.
Yeah.
And
Next slide.
the next tool for which C2PA could be integrated is the key frame selection and enhancement service tool. So this is a tool that was developed by the ITI cert. It's a tool to speeding up video analysis by providing relevant keyframes that were extracted from a video uploaded. It also provides an organized timeline and gets enhances faces and text detection for video analysis. So the way C2PA can be integrated is also to trace and verify individual keyframes by creating a manifest for a keyframe that was extracted from this video. So how we see C2PA working with this is a video gets uploaded to the service, whether it has C2PA or not, it's not relevant since C2PA, as we've proven, has ways to, if the video, of course, has its C2PA credentials somewhere, they can be retrieved through the soft binding mechanism. Here is an example of retrieving this video from that was generated by a different claim generator. And that video is attached with a new manifest that will be created by the claim generator. So the claim generator as the action as this keyframe was extracted, so it relies back to the original video. It provides a signature of when this extraction happened, and also under, of course, this all the information in the right provides even much more detailed metadata as of what is the shot number, the frame number, what is the timestamp of the extracted keyframe. And finally, this is signed with the keyframe certificate.
And it has been already implemented also in Eurovox, what you see, which is one of the products which the EBU is providing.
Yes. So this is the final result, and if we dig deeper now into the video that was recovered through the soft binding mechanism, this also will provide the rest of the provenance chain. So this whole example is example of implementation is to show that case can be extended with C2PA to provide or to make the provenance information of individual keyframes given as a C2PA video.
Mm-hmm.
And finally, the third service that we see C2PA can bring value to is the database of known fakes. So this is a searchable archive of debunked claims of and images and videos. It signs the idea here is to sign content to produce C2PA credentials using the database signing key to provide authenticity for the images that were published there. Most debunks provided in the database are could be mapped into a claim review metadata structure. So the claim reviews also all in the database follow the same structure, which could be mapped into a metadata space to provide the name of the fact-checking organization, the publisher, the review body. Here, this is where the text summary of the fact check or the debunk goes, the author of those fact check, if any item review, this will be the media that was also checked, and also any claim review. So the claim that was first introduced, which we didn't know the truth worthiness at first, which was debunked through this claim review. So here's again an example of a debunk that was published by DFP, which debunks this image, which was AI generated. The debunk included all the checks that were conducted and in what context this image was published, and also the platform in which it was published. All there went into the claim review, and then this claim review was attached or hardly bounded to the image, which was AI generated by once the debunk was published into the BKF platform. It was signed and recorded by the C2PA of this image. So here we can see the date on which this image was signed. Hopefully will be the same date as to when this debunk was published into the database, and also that it has been fact-checked by AFP fact-check. So this will provide trust to the fact-checkers or the news debunkers that are using the platform as of who published this and when it was published. So under the hood, the claim review is mapped into the manifest. Here is the complete fact check, which will also require adequate display, which is not currently supported by default by the C2PA official verifier. So other verifiers could be developed for this specific use case. Here, this is the claim review that the AFP published, the person that published it, meaning the author of the claim review, and also the item reviewed, which is the image of the Oscar statuette. And finally, this claim review is again signed by the platform database of known fakes upon publishing. So the key takeaways is that fact checks will be also hardbound to asset, and any tampering to any changes to these fact checks or to the content is tamper evident thanks to C2PA. Furthermore, as the database of known fakes implements media reverse search functionality, it can also provide now results with C2PA signed images with this guarantee of their claims being verifiable with C2PA, and also with fingerprinting technologies, the database of known things can also do the same thing by when fingerprinting this the images into the database of known things. And the benefit of using the claim review metadata schema is that it provides an interoperable way for different verifiers, whether it be a specific website or a dedicated verifier for claim checks, or even the Verify and vera.ai plugin. This this way of structuring the metadata in the manifest is interoperable, meaning that information can be extracted by the verifier and displayed by all verifiers uniformly. So
That's the report. So
that is the report.
yes, a lot of writing went into this by different people. Have a look. Please be advised, when you use your mobile phone to scan the bar graph here, this will not end up in good results. Use your laptop, it's much better. A computer to look at the report, because PDF on mobiles is sometimes a little bit strange to read. But it's available for everybody. There was a question just before about the BBC research. It's mentioned in the report, and there's also a link to the origin of the quote. You can read that easily to find. Next slide. And if you have time, there will be a lot shown at the IBC on implementations of C2PA by manufacturers, but we brought together on our booth of the EBU, also with the help of Badr and others, a wonderful demonstration. I think a set of nice demonstrations, which we also do together with the industry. So come by and have a look on what is demoed. There's also a special meetup on the coming Friday at 5 o'clock at the EBU booth in Hall 10 D21, where you can talk. You will meet, of course, Badr as well, meet myself, colleagues who are there, also from the EBU members who are joining our demo, also some of the manufacturers. And you see also France Television, who have C2PA now in production. And you see they also have received an award, the EBU TNI Award, for their pioneering work of implementing C2PA in their workflows, also together with manufacturers. So on the one hand, what we have shown to you is a technology, but the technology already has practical implementations and will help broadcasters to gain back trust in the content what they publish. It's a good methodology. We are still developing on it, but early implementations are very, very promising. But you have seen there is also a high potential for future, where we will use C2PA combined with other technologies, and then really to create value for broadcasters, but even more important, value for audiences who look at the content and consume content from media companies.